Okay, here's a tutorial startup for Qucs, which is quite universal circuit simulator. This is an open source harmonic balance simulator that supports DC, transient, AC analysis, harmonic balance, S parameter simulation, and it's something that I couldn't find a whole lot of tutorial help on in terms of the web, so I got familiar with it enough that I decided to post this. And so a significant beginning item here is to actually start a new project. And so over here in the simulation block area, we have projects, content, and components. On projects, if we just hit new, we'll call it demo. And this is a new project name. In content, there's a fair bit of information here that you won't typically be dealing with in the early stages of dealing with it. So don't need to worry about that. But components is what you really care about. And there's a wide variety of lumped element components. Important here is a sub-circuit port. So if you use a pair of those, then you can create a two-port sub-circuit. There's transformers, we've got current probe, voltage probe, even a circulator for microwave simulations, and Rs, LCs, transformers. Also of significance is sources. So here's DC voltage source, basically a battery. We've got DC current source, AC voltage source. The power source here is used for S parameter setups. So there's a number of source input options. There's also transmission lines. Some are just electrical only, some are physically based, and a wide variety of them. The nature of the models behind these I'm not familiar with. Digital components. There's gates, flip-flops, and apparently VHDL options in this. In terms of file components, from a beginner standpoint, not relevant. Simulations is significant. Here we have DC, transient, AC, S parameter, and there's a number of others down here, but we'll leave those alone for right now. DC is what we will start out with. In terms of diagrams, these are the different plot formats available. Cartesian will be very useful, probably the most used. This is where we get transfer functions for looking at filters or DC output, say looking at a voltage regulator, etc. A tabular output just gives you raw data. The beauty of QUCS is the Smith chart options for doing impedance measurements, and the fact that you also have a polar option, of course. And the paintings option down here is just graphics related to your schematic. So let's start off with a resistor. I left-clicked on that resistor, I moved over, has another one. We'll pop that down and then hit escape, and then we will left-click on this resistor, drag it down, and then edit and rotate. And let's just drop in here and make this a 500, so I will push in a 0 and hit enter. Likewise with this one, 0, enter. I'll hit Control R, bring these two together. And if we bring them together like this and then pull them apart, it automatically hooks a wire in there. We have a ground symbol up here, so we'll bring a ground in. We'll park another one here for our battery, and then hit escape to let go of the other extra ground. Come up here and left click on sources. And we will left click on the battery, bring that in, and then hit escape. And we'll left click into this value, and let's make this 10 volts. And we can come up here and drop a wire in, left click, left click, left click, escape. And then I'm going to add another wire here, just right here for convenience, and then escape. If I double click on this wire, this will be V out. Let's double click on this wire as V in. And we'll scroll down a little bit to make room for our simulation control. So in this case, we will come down to simulations, hit DC, and then escape. And we need to save this file since it's still untitled. So file, file, save as DC test. And now we can simulate by hitting the gear, clicking on the gear symbol, or the F2 key. And that list has been created. Everybody's happy. Now we're out in the display page. So we'll bring a Cartesian in. No, we will bring in a tabular. And we have V in as an independent, and we have V out, which we'll double click on. And then we will hit apply and hit OK. And escape to let go. Now you can see that V in is 10 volts, V out is 5 volts, as it should be. So that's basically a DC analysis, very simplistic, but a good example of how to get things started here in QUCS.